This week on the Tech on Tap podcast, we nerd out on Postgres and talk about how best to optimize it using Pganalyze with Lukas Fittl.
Welcome to the Tech on Tap podcast with Justin Parisi.
I love NetApp.
Oh, yeah.
NetApp. I love this company. Support.
I love NetApp because it's so funny.
Hello and welcome to the Tech on Tap podcast. My name is Justin Parisi. I'm here in the basement of my house, and with me today I have a special guest to talk to us all about Postgres, as well as things to do with Postgres and how to analyze and monitor it. So to do that today, we have Lukas Fittl. So Lukas, what do you do and how do we reach you?
Thank you for having me, Justin. So I am the founder and CEO of Pganalyze, which is a tool to optimize your Postgres database and essentially make it faster. You can reach me at lukas@pganalyze.com, or you can also find me on Twitter at Lukas Fittl, as well as Mastodon on the HashiNorm server.
All right, awesome. So let's dive into this then. Tell me, what is Postgres? I know that it's a database, but specifically, how is it different from other databases like an Oracle or a MySQL or a SQL?
Yes, I think what stands out about Postgres is that it's a fully open source community project that has been around for 27 years now. So Postgres just celebrated its 27th birthday. And I think what's remarkable about it is that it's not tied to a single company, and it's widely used today. Postgres for many people is the default open source database of choice. And I think what I truly find remarkable is that it has such a longevity, and that it has over the years shown that people trust their most important data into their Postgres database. And that 10 years from now, I'm pretty sure Postgres is going to be around and still be essentially the bedrock of a lot of people's systems, right? So Postgres really is one of the best choices for your system of record type database compared to, let's say, an Oracle, for example. You might find less tooling in the core product, but I think we've clearly seen these days that Postgres can perform competitively against Oracle, as, for example, seen when Amazon migrated all their main databases from Oracle to Postgres. So it really is the best default choice for a relational database today.
Okay, and let's talk a little bit more about the Oracle versus Postgres thing. I guess that it might not just be all a technical decision, but also a business decision, because an open source database is generally going to cost you less as far as licensing goes, but it may not cost you less as far as management goes. So tell me about the simplicity aspect of Postgres. Is it easy to use? Is it easy to install? Or is it equal to other databases out there?
And I think I would argue it's probably easier to install than Oracle is. And a lot of that really comes from the open source nature of it, right? If you want to install Postgres and you're using Linux, most of your distributions will already have Postgres bundled. So you can just do apt-get install Postgres, and it sits right there. And the same goes for many other systems. So the ubiquity of Postgres in many ways is also its strength, because if you need a Postgres database, it's going to be really quick. You don't need to talk to anybody. Versus if you need an Oracle database, I'm sure you'll have to, involve licensing and whatnot discussions. I do think from an ultimate, end user perspective, a lot of, modern applications actually will, integrate better with Postgres than with Oracle, because if you use any kind of modern framework, most of the time, all the ORMs support Postgres, but as far as I know, not that many support Oracle. Now, of course, that doesn't necessarily translate if you're more into Java or more on the enterprise side of the house, but I do feel that it's going to be easier for your developers as well to use Postgres these days.
And you mentioned that it's a relational database. So tell me about the difference between that type of database versus a transactional database.
That's a good question. And I wouldn't necessarily say relational versus transactional. I guess I would rather say relational versus, for example, document stores, right? So the classic modern comparison would be a Postgres versus a MongoDB, or also if another one, the columnar databases. So maybe ClickHouse is a good modern comparison there. And so I think the trade-off here is, what does your data look like and how would you like to query it, right? So if we compare it with document stores, for example, the big question there is, do you have structured data, right? Do you know what your columns are called? One thing that's interesting there in relation to comparison document stores is that Postgres is, because of its extensibility and because of its custom kind of data type support, also has many ways to actually store schema-less data. And so, for example, the JSONB data type in Postgres essentially makes it compete with MongoDB, makes it kind of be able to behave as if it was a document store by having this unstructured data. Now, I think what's interesting, if you compare it with columnar databases, sometimes there is a competitive performance benefit there to using columnar stores, right? So let's say you're looking at most of your data, all your queries, right? So you really want to do some level of aggregation across all your data. Oftentimes, columnar databases will be faster. So that's why I've seen many people using ClickHouse for these kind of special purpose workloads today. But then Postgres really will shine as the main system of record, even in those situations. Now, what I think is interesting there is that even with the columnar stores, because Postgres is extensible, Postgres actually has a columnar store extension these days. So there's actually two of them. There's an extension called Citus that I used to be involved with, and also an extension called Hydra. And so both of these are essentially columnar store extensions to Postgres, where for the part of your workload that you want to store in a columnar on disk format, you can actually use that just for that portion of your data and then use a relational format for everything else, like a row-based format.
So as far as choosing a database goes, if I'm starting out new, am I worrying about what application supports, or am I looking at certain aspects of a database to make that decision? And if so, how would I pick something like Postgres over something like MySQL or MongoDB?
I feel like oftentimes that decision is more, company policy of sorts, or maybe what the company has gotten into the habit of doing. So I speak with many data platform teams where Postgres has essentially become their database of choice. And so when an application team says, I have data to store, which data store should I use? Postgres essentially is the default that they would choose. I feel like it's less a project by project decision because the overhead of maintaining a new database system is certainly existing. So for example, if today all you had was Oracle, and then suddenly your application team said, Postgres is what I would like to use, then you will have overhead on the management side, on the DevOps side, to actually maintain these Postgres databases. And so what I would always recommend is taking that seriously, actually thinking, how can we make a good data store that actually supports our application teams well?
Okay. So can you give me some examples of well-known use cases for Postgres? I can imagine it being used in things like a social media use case, or maybe like a training of an AI model use case. Is that an accurate assumption, or is there other use cases that it fits better in?
I think it's really versatile, right? Some of the Pganalyze customers I can reference, for example, Atlassian uses Postgres and Pganalyze for pretty much everything, right? So if you create a Jira ticket, that ultimately goes to Postgres database. Now, let's say DoorDash, for example, right? If you order food to your house on DoorDash, it's going to be in a Postgres database where it ultimately tracks that data. If you use a Notion to take notes, they use Postgres behind the scenes. So it's very ubiquitous. I would say most modern apps that you're using today will be powered by Postgres database behind the scenes. And if it's not Postgres, then probably it's going to be MySQL.
So you're saying I could blame Postgres if my DoorDash order is late?
I'm sure you could sometimes. I don't have any unique insights there, but certainly I've sometimes waited for the screen to load. I was like, is this the Postgres being slow?
It's either that or the network.
Right, exactly.
One of the two things, right? So speaking of Postgres being slow or not, I would imagine there are some considerations you need to take into account when you're setting this up. So tell me some of the things you really need to think about when you're actually using a Postgres database.
I think from an operational perspective, if you're thinking about this from let's say, how do I set up my VM or how do I set up my storage? I think it's important to remember that ultimately, from a resource perspective, it's the typical things you need to think about. Think about CPU, think about RAM, think about I/O. And I think one thing where Postgres is both good, but then also very sensitive to the performance of it is the storage, right? So you generally would want most of what we call the working set to be in memory. And so when it comes to sizing your instances from setting it up at the first time perspective, really think about how much of your data are you going to be frequently querying, and ideally have that data in memory. If you don't have it in memory, ideally have a really fast storage attached with low latency, because ultimately a lot of times that's where you'll find the bottleneck, is if your storage is slow and then the query essentially has to wait for that storage to return its results. I think that's from a hardware perspective. I think from a software perspective, probably I would recommend hosting it on Linux, even though Postgres can run on Windows. It's definitely going to be, I think, easier to maintain and better to set up on a Linux-based system or theoretically BSD-based system.
So you mentioned Linux and Windows, and that got me thinking about the latency aspect of it. When we talk about hosting on external storage, we're talking about a protocol. Are you seeing Postgres installed more on a block protocol or on a NAS protocol or a little of both?
Yeah, it's a good question. I mean, these days, I would say most of the time I actually see it installed as in the cloud, right? And so there, I would say it's probably more like a block type protocol. So if you think about an EBS volume in the cloud, for example, like on Amazon, it's going to be exposed as a file system ultimately. And so I think that file system usually is going to be mounted more over something block based versus like NFS or something. I don't know if that's strictly necessary. There's some operations that Postgres likes to do. For example, it wants to make sure it f-syncs the data correctly and stuff like that. And so I do think that for some of these operations, it's better suited to use a block-based protocol. But you're probably more an expert than I am on the actual low-level storage side of the house.
I know that we have a lot of customers that use our stuff with databases, and they're perfectly fine with using NFS. And I think it really comes down to, what do you need? You can always look at the edge cases and the maximums and say, oh, well, this thing can do 60 gigs a second or something. But that might be overkill for your database. You might not need that. That said, what's more important with Postgres? Is it more important to have low latency, high operations, or is the throughput going to be important there?
I would say it's probably more latency bound than throughput bound. I mean, I've seen databases be bottlenecked on throughput, but I think especially in any kind of network storage type situation, latency is going to be the more important metric to watch out for. Postgres today does a lot of synchronous I/O. So Postgres will often issue an I/O request on the software side and wait for the result to return. There's some cases where it does prefetching, where we'll advise the kernel that it's about to meet something so the kernel can do the prefetch. But I think we don't yet today in Postgres have asynchronous I/O. There is a really interesting project going on that we'll see in the next Postgres release cycle. We'll see some progress on asynchronous I/O in Postgres, which I think will reduce the issues that you see with higher latency storage today. And so I would say today, definitely optimize for latency before you optimize for throughput.
And when you say synchronous versus asynchronous, I'm guessing that's what you mean is basically the Postgres database will leverage the client's RAM to cache things and then push it all to storage after a certain amount of time to reduce the amount of latency cost that's going to come when you need to answer a question quickly by the database. Is that accurate?
In a sense. So the way I would think about it is ultimately it's just software. And so let's say you have a write, so you're doing an insert, and then Postgres will, in some cases, actually wait for the storage device to finish certain operations, and then we'll do the next operation. So on a write, you can sometimes see impacts of that waiting for the I/O to complete. Now, the same thing happens on reads. For example, in reads, one thing that Postgres does today is when you do an index lookup, and Postgres does what's called a bitmap index scan, a bitmap heap scan. So from the index, essentially, it gets the locations of the table it's interested in, and then it will tell the kernel, please fetch these things for me because I'm about to need them. And then when it actually fetches the data from the I/O request, it's not going to go to actual disk. It's going to be in the kernel page cache. And so think about asynchronous I/O as a much more versatile option of that. So instead of like relying on the kernel to do this prefetching, the database itself will be able to batch I/O requests together and actually be able to, in many cases, merge those I/O requests on the kernel side. And so it's going to be much more efficient to do I/O instead of waiting for I/O to complete and then do the next I/O.
And what about things like Optane memory? Is that overkill for this type of workload? Is it necessary? Is it useful?
I haven't done any benchmarks personally. I do think the thing with Optane, it's so expensive. Nothing against Optane, but like it's very expensive to deploy. And I do think you would see a performance benefit. So I don't think it's a bad choice necessarily, but I do think the cost benefit analysis probably is not going to weigh towards it. I think there are probably more price competitive choices, just like if you have a good NVMe enterprise SSD or some other kind of low latency storage option, I think that's going to usually perform better in terms of price, kind of cost benefits versus going for something extreme, I would say, like Optane.
Yeah, I mean, that might be overkill. And again, it comes back to what do you need? What sort of operations do you need? What sort of throughput do you need? What's your application going to require in terms of response time? Because that's going to really dictate what you use for the back end, because you don't have to always use FCP or NVMe on the back end. You can probably get away with using NFS in a lot of cases.
Yeah, that makes sense. I would say ultimately run a benchmark. Test your workload, test something that looks like your workload and has the kind of throughput or latency that you would want to see in production in that benchmark, and then actually validate that whatever choice you make is the right one.
And what are the benchmark tools of your choice? Are you leveraging something like FIO or something like a Postgres benchmarking tool that's built into the product? What are you leveraging?
I think on the storage side, definitely start with something FIO, right? FIO is, I think, a great choice to just get a baseline of what's your storage doing. I think on the Postgres side, so Postgres has pgbench bundled, which is a rather simplistic benchmarking tool that just runs standard TPC, if I recall correctly, event workload. And so you can use pgbench, but it's not necessarily going to test every aspect of it. pgbench does have support, though, for custom scripts. And so what you can do is if you know you have a set of queries that you would like to test, you can actually use pgbench to essentially have it run those queries multiple times across different variants of the subset of your data, and that way produce a more realistic looking workload. There's also HammerDB, which is a great benchmarking tool. And HammerDB lets you test like TPCH and other standard database benchmarks.
Yeah, and those are pretty standard tools that you'd use for any type of database testing, I would imagine, right? So not just Postgres.
That's right. Yeah, HammerDB, for example, you could test MySQL or ClickHouse as well.
All right, so we've gotten to the point where we're talking about database performance, and I guess this is where Pganalyze comes in. So tell me about what Pganalyze does to help optimize database performance for Postgres.
For sure. Yeah. And let me maybe take a step back and tell you a bit more about the history of where Pganalyze started. So I'm an engineer by trade. And about 12 years ago, I was just an engineer working with Postgres. And what I struggled with at the time and where Pganalyze really comes in is optimizing query performance. So Pganalyze started as just giving you visibility into which queries are running on your Postgres database, just giving you the snapshot of in these 24 hours, this is every little query that ran both fast and slow on your database so that you can understand if your database is slow, is it because there's this one query that's constantly doing a sequential scan, for example, instead of an index scan. And so over the years, we've evolved Pganalyze from doing the database monitoring to really being a very, I would say, versatile and sophisticated tool to give you tuning recommendations and to also show you all the different aspects of Postgres. So for example, recently we launched a new feature called the vacuum advisor. Now, auto vacuum, if you're not familiar with it, is a very essential process in Postgres, which ultimately cleans up the data. When you do an update in Postgres, that data has to be cleaned up. And so auto vacuum comes in and does the cleanup. And this is something that's very particular about Postgres that you wouldn't necessarily find in Oracle in the same way or in MySQL in the same way. And we've seen many people struggle with configuring it. And Pganalyze will give you specific tuning recommendations for your workload based on the queries, based on the table statistics, and tell you you should change this configuration setting to essentially get better performance and kind of less load on the table. Where we see Pganalyze today is really the companion to the database engineer, to the backend application engineer, to make sure that your database is performing well. And then if it isn't performing well, that you understand why it's not performing well. And so you can really dive into the details and see exactly which query, which execution plan is slow.
So how granular can it get? Can it tell me where exactly my bottleneck is, whether it's client CPU or storage latency or the actual queries themselves?
Yeah, I think it depends a bit on where you're running. We're, of course, limited by what Postgres itself offers us. So if you're running in the cloud, you can't just run BPF trace or something. But what we'll do is we'll show you the individual execution plans, and then in the execution plans, we'll highlight to you, for example, which one is IO heavy. And so you'll notice that when you have a really slow query, the reason the query is slow is because on one of the parts of the query plan where it does a particular lookup on a particular table, that's the part that's slow. And what makes a big difference is actually diving into this and really optimizing that individual lookup on that table. I've seen drastic performance improvements. Recently, I was optimizing something, query was running for over 1,000 milliseconds. And after just improving a little bit of an index, it went down to less than 5 milliseconds. These type of improvements are oftentimes really specific parts of the query that are slow.
Yeah, and working in the support center for a few years here at NetApp, and I know that a lot of times we'd get database cases and they'd point to the storage, they'd point to the network. And honestly, a lot of the times it was the query. Like it wasn't an efficient query. It wasn't written in a way that was going to work properly no matter where you put it on. So is that something that you see as well out there with the database workloads and the problems that you see with performance?
Yeah, I think it can certainly be an issue. I think sometimes people don't really write queries necessarily. Oftentimes it's an ORM generating a query. What I see is people not even being aware what query they're running. And then, of course, then translates to that pattern being in the query. Think about your database as an extension of your application. Your database is just software ultimately. So understanding that if you're running a query, there is something the database actually has to execute a certain functionality to get that data for you. And so not thinking about the database as this magic box that just gives you data, but really trying to introspect it and trying to understand how it will get that data and what the physical layout of the data looks like will make you understand that maybe you wrote the query inefficiently. Maybe you told the database to get all the data first, and then you reduce the data you're looking for. Maybe you should introduce a where clause or introduce a different join clause.
And can Pganalyze actually analyze the database structure itself to see if it's been created in a way that's efficient, that you're actually having the data sorted in a way that you can access, or does it not go that far?
We do some of that. We can always do more, but I think the part that we do today is we focus on indexing a lot. So indexing, you create, let's say, a B-tree index, for example, and ultimately that's a caching structure. So instead of Postgres just going row by row through your main table, it will be able to use the index to do a more efficient lookup. That can also be used for sorts, of course, or other kind of benefits. What we do today, when we Pganalyze, we look at your query workload. And for each of the queries that we see in your query workload, we'll parse it, we'll actually plan it using a copy of the Postgres planner that we have in our application, and then we'll come up with the best possible indexes that could exist for those queries. So imagine as us reverse engineering which type of index the Postgres planner would like to see. And then we have a system that gives you index recommendations. And it's not necessarily that you have to change the query. Oftentimes it's just that you have to create the right index that matches the where clause of the query.
And how prescriptive are these recommendations? Are they just basically, hey, change this, or does it give you the whole command line structure to try to address that?
They're fairly prescriptive today. It's certainly a create this index. It's very direct in that sense. What I think is unique about our system is that it's very deterministic. This is not magic AI sprinkles, but rather it's a system that we developed, which we call an expert system, maybe in old school terms, which looks at all those aspects of the workload, and then has a model that it uses to come up with the specific recommendations. One thing that we're currently working on, which I'm really excited about, is a way to customize that selection. So generally, this problem is known as the index selection problem. There's been a bunch of academic research on this. What we've developed recently, early this year, and we're still in the process of releasing it, is essentially a new index selection model for Postgres, which lets you use constrained programming to identify the indexes that should actually be used for your workload. And you can then customize that selection by saying, I would actually like to have as little indexes as possible. I want to keep my write overhead low, which is each index adds write overhead. And so I want to use a selection for my indexes that actually is very optimized towards write overhead being low. In other cases, maybe you really want to get the best read performance out of it. So we'll have an option to say, I want the best possible performance, the perfect index for each query. That's something that we'll be releasing later this year. But I think that's really going to be giving you a whole different experience, because you're going to be able to say, what's my indexing strategy for my database? And you're going to be able to encode that in the Pganalyze application. And then Pganalyze will give you the specific commands to run, or in the future version also will potentially run them for you if that's what you like.
Yeah, that was going to be my next question. Does it actually have a way to do it for me? Because you can copy and paste commands all day long, or you can go Google the commands. But like ultimately, a lot of people just want it to do it for them. They don't want to deal with all the extra aspects of that. So it sounds good that you're going to add that particular functionality into the product later on.
Yeah, and what we've seen is automation always sounds exciting, but ultimately people want to have control over automation. What a lot of people want is not necessarily the just make it work magically and don't even tell me, just do it. But rather what they want is a system that at least informs them of what it's doing and why it's doing it, but in many cases also has an approvals workflow. In many cases, people would rather have a pull request or merge request that says, here's an index recommendation, click merge if you want to apply it to your database. What they actually want to see is the data that supports that decision. They don't just want to have the system do it automatically for them. They actually want to have the system educate them, the system inform them, and then them being in control versus the system being in control.
So let's dive a little bit more into the index aspect here. It sounds like an index was going to be very important for maintaining your Postgres database, or any database really. And as far as I understand it, it's a way to help speed things up overall. But can you dive a little bit more into indexes and how they interact with databases specifically and why they're important?
Right. So indexes are a secondary data structure. So they don't store your primary data. They're just there to help do a lookup faster. And so today, when you say create index in a Postgres database, it will give you a B-tree index. B-tree indexes are very universal. B-tree indexes exist in Oracle, in MySQL, and in Postgres, and many other databases. B-tree is good for many things, but it's not always the best index type. What's interesting with Postgres there is that Postgres has special purpose indexes. Let's say I'm a cab company and I want to know how many of my cabs are in Manhattan versus Brooklyn. I can do a search with a special purpose index that is able to do geographic lookups. And you can say, are these coordinates within that polygon, like the city? And there's ways to index that efficiently with SVGIST indexes in Postgres, for example. What's really fascinating to me with the Postgres index types is that depending on how your data is structured, oftentimes particular index types make a lot more sense. And so it really helps to do a little bit of research and trying to understand what you're trying to do. You're trying to find a needle in a haystack. How exactly are you trying to do that? And what does the haystack look like? Another good example would be Postgres recently added a couple of releases ago an index type called BRIN. BRIN is short for block range indexes. BRIN is really just a small helper that says, for this particular value, where in the table is the value most likely going to be? And so it doesn't actually answer the question where exactly in the table. It just helps narrow down the search. And because of the way BRIN stores this data, for certain cases where your logical row ordering and your physical row ordering are essentially the same, which read up on this if it's interesting to you, but the gist of it is in those situations, BRIN indexes outperform pretty much everything else because they're just so small and they can always be kept in cache and help speed up the lookups in those cases. And so what I would say, if you're thinking about working with indexes in Postgres, sometimes it's worth looking beyond the B-tree index type and looking into these other index types. And of course, if you're looking to work with vector data, then IVF flat indexes and pgvector are a good look as well.
All right, so walk me through how Pganalyze is going to help optimize things like an index or optimize the client settings. What is Pganalyze going to be doing in those situations?
So it helps you find the things that you might have forgotten. The typical situation is an application engineer makes a change to the app. Through the change they're making, they add a new query. Maybe they forgot to think about that query. Maybe they did think about the query, but they forgot to add an index. And so that goes live on your production system. Now what happens next in many cases is if it's a really bad situation, the moment the change hits production, things go south, right? your whole database is going to be slow because suddenly all the new queries that are coming in are just going to overwhelm the database. Or sometimes what happens is the new part of the application is slow and everybody's asking what's happening. With Pganalyze, the experience is that in that moment, when we detect that situation, we will be able to send you an alert. For example, let's say you're using Slack. If you have a Slack channel for your application team, you'll actually be able to see missing index alert right away. In that situation, you could just copy the create command and apply it to your production database, and then the issue would be fixed because the sequential scans that are often the problem here would then be resolved.
Does Pganalyze only work with Postgres? Can it interact with other databases, or is it specifically tailored to Postgres?
We've made a really particular choice to only support Postgres. We've certainly had the requests over the years to support MySQL or even, I think, support Oracle at some point. And I think for us, there's a trade-off here because ultimately, if we say we want to grow our business, we could say, let's just support every database that's out there. But what we found is that oftentimes the companies that we work with, they really think that Postgres is the right database of choice for their environment. They think that for their system of record type applications, Postgres is the main choice. And so we've been able to do a lot of in-depth analysis of what's the perfect index for this query. Then we actually run the Postgres planner, and we have a copy of the Postgres planner source code in our own application. That level of analysis, if you extended that to 10 different databases, in some cases you couldn't even do it because Oracle is not going to give you a copy of the Oracle planner. So you're not going to be able to actually figure out how it works behind the scenes in the same level of depth. For us, it's been a very deliberate choice to say, we think Postgres is the best open source relational database. We think we want to make the best product for Postgres. And we've seen good success with this. One recent survey last year by the folks over at TimescaleDB, they've asked which tools are people using with Postgres, and so Pganalyze came out about 12% of usage, right? So 12% of all Postgres users that they surveyed are using Pganalyze, which to me was surprising because I'd like to think of us as little fish trying to go bigger, but it's really nice to see in that sample size, we already had a quite substantial number of people using Pganalyze and being aware of Pganalyze.
Plus, if you added more databases, you'd have to change your name.
That's true. Could be Myanalyze, right?
Pganalyze. There we go. Oh, probably already taken. What sort of data protection controls are in place there? So like if I apply a change that Pganalyze recommended, is it going to give me the option to roll that change back? Do I have a way to get out of that situation if I didn't like what happened?
Yeah, for sure. The good news is both indexes and settings changes are pretty easily rollbackable. So an index, you can just drop the index. We have a system that also detects when an index is unused, which because of how things work out, sometimes even though you create an index, Postgres actually doesn't end up using the index. It will detect that and tell you about it. And many settings in Postgres are reloadable, so you can just apply a change to them if the change didn't work out.
And what about interaction with external backup products like an NDMP backup or leveraging snapshots with, say, a NetApp device or something like that? Does Pganalyze have hooks for that? Can I build that in with APIs, or is that not something that's there?
We don't really do much in Pganalyze with that today. To be honest, I think it's more of a Postgres problem than a Pganalyze problem. It's more a question of how do I back up my Postgres database? And what you just mentioned with snapshots really comes into play there. Many times in the cloud, the most efficient way of doing things will be to use the kind of the storage snapshot feature. And so there are best practices around that with Postgres and how you do these type of backups. But it's not really something that we at Pganalyze concern ourselves with today, because for us, there is best practices and it is a bit situation specific.
So even though there's not really a hook into Pganalyze, is it something that you would add as a best practice? Like, hey, before you make this global change to your database, maybe consider taking a snapshot or maybe consider backing the database up first.
Oh, yeah, sure. If you have a way to have snapshots of your data, what I would actually recommend is booting up a copy of your database. In many cases, before you actually apply a change to your productions, the best practice is using a snapshot feature to create a copy of the database, run tests there, like test the new index on this copy of the database, and then actually apply it to production. So I would rather look at it from that perspective versus rolling back, because rolling back is really expensive. A production database is being actively used. And so even if you had a snapshot from 10 minutes ago, it doesn't really help you because you can't just go back and lose that data from the last 10 minutes.
Yeah, that makes sense. It's also good to make sure that what you're changing is going to work to begin with. You want to see if the recommended changes is going to do what it's promising to do.
That's right.
So Pganalyze, where would I find it? How would I get to it? How do I license it? Is there a trial period?
You can just find Pganalyze at pganalyze.com. We do have a 14-day trial you can use. And then we have two different versions of Pganalyze. We have a cloud-based version, which works like other cloud-based products. You send data into our cloud monitoring environment. And then there's also an on-prem enterprise product that people can use to deploy behind the firewall. We've often seen people that either more from a compliance perspective or data privacy perspective, they don't want to send data into the cloud. And so we do have an option of Pganalyze Enterprise Server that essentially runs fully within your environment. so that all the data stays local in your environment.
And is this an appliance or is it an agent or a software that you install on a server?
So in the cloud version, it is essentially an agent. So somewhere in your environment, you will have to run that agent that collects the data from your Postgres database. And it's depending on how you set up your database. If it's a cloud-based version of Postgres, if you're using Amazon RDS, for example, then you would just run virtual machine or Docker container with our collector software that gets that data from the Postgres database and also from the AWS APIs. If you're running on-premise, oftentimes we recommend installing that agent directly on the database server. That way it's actually able to collect some of the operating system statistics as well, like IO utilization and such. And so that agent then in the cloud setup sends it back to our central installation. In the case of enterprise server, it's a Docker container that you deploy in your environment. So for example, if you have a Kubernetes environment, you should have a pod running the Pganalyze software, and then either you can have that agent running or it's all the central container connecting out to the Postgres databases and collecting data.
And am I able to use this on any cloud, any platform? Does it really matter?
Pretty much, we support any of the major cloud providers directly. If we don't officially support provider, you usually can still use it. It's just that we haven't documented it, but it doesn't require any custom extensions. All it uses is built-in functionality in Postgres.
And is there any specific Postgres version that I have to be on to use Pganalyze, or does it care about that either?
No, we support all the published releases. What I would say in Postgres versions, if for some reason you're still on Postgres 10, make sure to upgrade because Postgres 10 is about to be end of life. Same for Postgres 11 is also on the way out. So just make sure you get the latest releases from a security perspective. But from a Pganalyze perspective, technically we can support even the unsupported releases.
Any plans for a managed service type of instance of Pganalyze where you don't have to do anything but just click a button and start running it?
On the enterprise side, there is certainly some interest in that. I think the reality, though, is everybody's environment looks different. So I think we've moved away from the age of appliances. I think the closest to it would be a virtual machine image in the cloud these days. There isn't really a best practice that I've seen where there's just this one way of deploying in enterprise environments where it just works. And so what we found works best is asking our customers, how would you deploy your own applications? And if they deploy their own applications of Kubernetes, then we recommend just launch Pganalyze in Kubernetes. If they deploy their own applications on a virtual machine, we say use a virtual machine. And so we try to adapt a little bit to each customer's environment that way.
And does this fit into the picture with automation suites like Ansible? Do you have any sort of runbooks or recipes out there for Pganalyze installation and management?
Yeah, I mentioned for Kubernetes, we have Helm chart for the collector, and then we also have the templates for the main enterprise server. We don't have anything for Ansible specifically today. One gap in the automation world, I would say, is when you think of managing Postgres settings, for example, what I oftentimes find people lacking is a good way to really manage the database itself in an automated way. So if you think of Ansible, oftentimes Ansible would maybe control the base setup of the image and have the OS, but it doesn't really get involved with the actual database management side of it. Of course, you could install Pganalyze that way, right? But it feels like still in the whole world of Postgres automation, there is a bit of a gap there where Ansible or Terraform don't really do enough of the database specific work.
Okay. So give me a customer success story or two. Tell me about some customers that have used this and what sort of results they saw when they dealt with Pganalyze.
For sure, yeah. If you're interested in a specific story, and on our website we have a story with Atlassian. Atlassian has been a Pganalyze customer for many years. They used it widely for all different products internally. I would recommend checking out that story. One particular note that I recall from that case study is that what they've really found key to see about their workloads is not just the slow statements. Oftentimes you have a system set up to log things that are slow at a certain threshold, but what Pganalyze really enabled them to do was also see fast statements that were just running along. So you can imagine an application that kept issuing the same query over and over again, and even though the query itself was fast, because of that overhead of querying the database and doing the network latency round trip to a database, they saw a problem there. And so Pganalyze ultimately helped them identify these frequently running queries that were fast. There's many more details in that particular case study, but what they've really found is that it applies universally to their different product suites, be it Confluence or Jira or other internal APIs. Pganalyze has really helped the different application teams scale Postgres better.
What sort of instances have you seen an extreme savings in latency or an extreme savings in time spent in the overall queries? Give me a percentage or a latency number that you've seen.
For sure. So we use Pganalyze to optimize our own database, which is also a Postgres database. And so I can share something specific there. So this is from early this year when we were optimizing a particular query. There was essentially a change here where we ultimately added a missing index. The improvement was a 500x improvement, which sounds like a really big number, but ultimately that was a query that was before running with 70 milliseconds, and it went down to 0.1 milliseconds. And the main reason why that was such a stark contrast in terms of the runtime was because Postgres was able to first get the data on one of the tables, then get the data on the other table, and then do a hash join to merge these tables together. And so oftentimes in Postgres, when you don't have a good set of indexes and you write your queries in a bad way, you see what's called a nested loop. And a nested loop can sometimes be a reasonable choice for an index. But in this particular case, really the problem was that nested loop just ended up being really expensive. And so Pganalyze was able to, in our own case here, show us that missing index. And then we were able to get that 500x roughly improvement from 71 milliseconds to 0.13 milliseconds, which is exactly the kind of stuff that I would like to see, right? Like when I'm doing performance debugging myself and I get that level of improvement, it goes from a slow experience to something that's barely noticeable. It just runs really quick and it's right there.
Yeah, and on the end user side, it's the difference between searching for something on the web and having it take 2 seconds versus taking 1 second. It may not seem like a lot, but it's the little things that count. And it also helps reduce the load overall for the database because the less time queries take, the more queries it can service coming into the system, and you're not spending so much time in CPU and RAM.
That's right.
So everybody knows the hot button topic of the day is AI and ChatGPT and all those other AI-centric things. So as far as Postgres goes, where does it fit into the AI landscape?
I think what's really interesting with Postgres is coming back to what I referenced earlier is extensibility, right? So Postgres has data types on your tables, and these data types can be customized. You can write your own extensions for that. But in the context of AI and ML, one extension that has really caught a lot of attention early this year and still continues to be really popular is called pgvector. And so what pgvector does is it stores your embeddings in a Postgres data type that's customized for storing embeddings for ML type data. And so what you can do is you can use open APIs to get that embedding data stored in Postgres and then use pgvector's search functionality to do similarity searches using those embeddings in an efficient way. And what's really fascinating with this is we referenced earlier the different database types like column stores and such. And so another new database type that has emerged are vector databases. What people do when they want to work with OpenAI data, for example, they actually end up deploying these special purpose databases that are just really good at storing AI data. Postgres with the pgvector extension was able to make Postgres extensible and allow you to really run these similarity searches efficiently. And the good news is pgvector is an open source project. So again, shows Postgres is really a good open source database and it's widely available. So if you're deploying Postgres in the cloud today with a managed provider, you'll get pgvector supported. Of course, you can get it on-prem as well if you built your own Postgres. And at Pganalyze, one of the things we're looking into for index recommendations is to also, in the future release, include recommendations for pgvector indexes. Pgvector has a special index format called IVF flat, which is very different than other index types in Postgres. That special purpose index is good for doing similarity searches. It's based on recent research in the ML space. What we're looking to do also in the future is give you index recommendations for your vector workflows. If you're using pgvector and Postgres and you want to know which indexes to use or what to index on those databases, then our goal is to also offer that for you as part of Pganalyze.
All right, sounds like Pganalyze is pretty widespread and pretty well used with the Postgres world. So tell me, if I wanted to find more information about Pganalyze, where would I do that?
If you just want to take a look, go to our website, pganalyze.com. If you're interested to hear what's new with Pganalyze, we have a monthly newsletter that you can subscribe to on our website. And then I also host a weekly show called 5 Minutes of Postgres, where I just feature interesting aspects of Postgres each week, talking about what different folks in the industry and the community have talked about Postgres. So if you just want to get 5 minutes of information each week, subscribe on YouTube to our YouTube channel.
Awesome. And again, Lukas, if we wanted to reach you, how do we do that?
Feel free to email me, lucas@pganalyze.com. That's Lukas with a K. That's important detail. And then if you just want to find me on social media, feel free to connect with me on Twitter or Mastodon or LinkedIn.
It's X now, Lukas.
That's true, yeah. I saw the app logo change the other day. I was like, geez.
Yeah, they're really leaning into that. So whatever. All right, cool. Well, thanks again for joining us and talking to us all about Postgres. And we learned a lot of new things here and telling us all about Pganalyze.
Thank you so much for having me.
All right, that music tells me it's time to go. If you'd like to get in touch with us, send us an email to podcast@netapp.com or send us a tweet @netapp. As always, if you'd like to subscribe, find us on iTunes, Spotify, Google Play, iHeartRadio, SoundCloud, Stitcher, or via TechOnTapPodcast.com. If you like the show today, leave us a review. On behalf of the entire Tech on Tap podcast team, I'd like to thank Lukas Fittl of Pganalyze for joining us today. As always, thanks for listening.
Oh, yeah. Is it just me that's getting off on this?
Oh, yeah.